Welcome to Learning to Engineer. Today we are going to solve another problem by using superposition theorem. Already we would have solved more than 3 problems by this theorem, and there is one tricky thing to learn from this problem. The moral, or that's how I put it, okay? The moral of the problem that we are going to see is that mind the direction, okay? Whenever we solve a problem, I put it this way: whatever is the point that we need to focus on in order to solve the problem correctly, I name it as the moral of the problem. Just like we say moral of the story. Okay, so the moral of this problem is going to be mind the direction. When we eliminate a power source, when we consider one power source only, we need to find the direction of I3 according to the direction in which that particular source supplies power. So that is the theme of this problem. So if you are very thorough about superposition theorem, and I'm sure you are, I know you have watched this video, I'm sure you are thorough about superposition theorem by this time. So pause this video, quickly solve the problem, then continue watching the video after you have the answer for I3. In this problem, we need to find the value of the current I3, that is through this branch which is supplied by 3 sources, and you need to apply superposition theorem to find that. This problem can also be solved by many methods. You can solve this by using mesh analysis, by nodal analysis, or any other technique that you are comfortable with. So I'm asking you to use superposition theorem so that you are sure about the direction in which you find the current I3. Okay, when you eliminate the power sources one by one, there is a chance that you will make a mistake when you are not mindful of the current's direction. Okay, so pause the video now and start solving the problem by yourself. See you soon. In the first case, I have considered only the 8 ampere current source. I have shorted this 100 volt source and the 60 volt source by a short circuit. Okay, so now I am going to find I31, which is contributed by 8 ampere source only. So in the problem, the direction of the I3 is from bottom to top. This is the I3's direction that is given. I am considering this current as I31. Okay, and when I supply 8 ampere from this terminal, the current is going to get distributed and it is going to enter the short circuit from top to bottom. It will come in this direction, which is opposite to the considered direction. So I31 will be a negative current. This is what you need to be mindful of, like I said before. Okay, so since we have a short circuit, the 8 ampere will be splitting into the 50 ohm, then into the 30 ohm, and then nothing will go beyond the short circuit. Okay, all the current which is entering the 30 ohm, since this path has least resistance, this current will directly flow into this short and then circulate back to the source. No current will enter through this 30 ohm and through this 60 ohm. Okay, because of this short. So let me find I31. By applying the current division rule, I can say that I31 will be minus total current 8 ampere into the other resistance 50 divided by sum of these two resistances 50 plus 30, 80 ohm. So this will be minus 5 ampere. Okay, I31 is minus 5 ampere. In the next case, I am going to consider only the 100 volt source and I am going to open circuit this 8 ampere source and this 60 volt source. I have a 30 ohm and then a 50 ohm. See, I have open circuited this 8 ampere current source and I have short circuited this 60 volt source. I only have one source here, which is this 100 volt voltage source, and I am considering this current to be I32. Okay, I32 is actually supplied by this 100 volt source and then it splits into left and right branches. In the right branch, since the 30 ohm and 60 ohm are in parallel, this right branch current divides. In the left hand side, the 30 ohm and 50 ohm are in series. So this left branch current enters fully into the 50 ohm and then it circulates back to the 100 ohm. Okay, this is our circuit now. If I could simplify this circuit a little bit, I can say that I have a 100 volt source, and across this source I have two sets of resistor, 50 plus 30, 80 ohm on the left, and then 30 parallel with 60. I quickly write it here. 30 parallel with 60 will be 1800 divided by 90, which is 20 ohm. So on the right side we have 60 parallel to 30, which is 20 ohm. This is 20 ohm, and on the left 50 plus 30, 80. We have 80 ohm. So this is our simplified circuit, and I32 is this current. We have to find this current, I32 supplied by 100 volt. Sounds easy, right? What is I32? I32 will be sum of these two currents, which is 100 divided by 80 plus 100 divided by 20, which will be 100 divided by 80 is 1.25, 1.25 plus 5, 6.25. This current is 6.25 ampere. Alright. So I31 is minus 5 ampere and I32 is 6.25 ampere. Next, we are going to kill these two sources and then have only the 60 volt source. Due to 60 volt source, we will be finding the current I33, which is the current supplied only by 60 volt. If I solve this circuit, I will be open circuiting it. Okay. So if I open circuit, I will have 50 in series with 30, 80 here, and then we will have a short circuit. Then we will have 30, 60. And due to this short circuit, what will happen? The current supplied by 60 volt source will not enter the 60 ohm. It will directly go into the short. Okay. So if I do the circuit will look like this. 30 ohm. I have short circuited the 100 volt source and I have open circuited the 8 ampere current source. So what happened? The 50 and the 30 became in series, and due to this short, the 60 volt voltage source will supply a current. It will go into the 30. It will not go into the 60. It will directly go into the short and then get circulated back into the source. This current will go into the 30 and then it will fully rush through the short. Because short circuit offers least resistance, current often chooses the path of least resistance. So through this 60 ohm, no current will flow. It will flow directly into the short circuit and then this short will be connected back to the source. So this will be the current's path. So in the current's path, what is the resistance? In this path, there is only one resistance, which is 30 ohm. The current flows only through the 30 ohm resistor. According to the problem, the current direction is from bottom to top. So I33 is also from bottom to top. This is a negative current because this current is in the opposite direction of our circuit's considered current. So I33 will be minus of 60 divided by 30. So I33 is minus 2 ampere. So what is the total current? The total current I3 will be I31, the current due to 8 ampere source, plus I32, this current is due to the 100 volt source, plus I33. And I33 is the current due to the 60 volt source. We have three sources here. Okay. And what is I3? I3 will be minus 5 ampere plus 6.25 minus 2 ampere. I3 will be minus 0.75 ampere. So this is the theme of this problem. In the first case, I3's current was opposite to the direction of the current which is considered in the circuit. In the next case, I3 is actually along the assumed direction. Then in the third case also, 60 volts supplies current in the direction from top to bottom. So I33 is opposite to the circuit's current. So these two currents were negative. We have to mind the direction and algebraically add all the currents to get the current I3. Okay. I hope by this time you guys would have watched my videos on superposition theorem. One video was on the method of superposition theorem, the definition and the terms and the conditions where you can and you cannot apply. And the next video will be how to apply superposition theorem to a circuit. And there will be another video on the dependent sources present in a network and how to use superposition theorem when you find a dependent source. So by these 4 problems, I hope you would have understood superposition theorem better, and very soon I will be teaching you a method called source transformation technique. If you have a current source in parallel with a resistor, you can convert it to voltage source in series with a resistor. So I will be talking about this method more and more in my future videos. And I hope once you see those methods, you will mostly avoid using superposition theorem, because whenever you see a network, you will be able to quickly transform that technique in a easier manner so that you can find whatever you want. So we will see more about source transformation techniques in my future videos. Thanks for watching, and if you have any comments about this topic, let me know in the comment section. You can also mail me to learningtoengineer@gmail.com, and you can tell me your thoughts about these videos, and you can also tell me if you have any doubts. If you have any tricky problem which you are finding it difficult to solve, just take a picture of it or just type the problem in the comment section. I'll be happy to solve that problem for you in this channel. Thanks for watching.